All right, good morning, everybody. How are you? Amy, you are aware it is not your color day today. Unless you switched. No, you emailed me about that before, didn't you? Never mind. I already knew, but I forgot that I knew that I knew. Anyways, welcome to here. Yeah, send an email. It just now clicked as soon as I said it. If only my brain would work faster than my mouth sometimes, we might actually get somewhere. Anyways, before we get into today's super awesome stuff, there are actually several announcements now that we are approaching the end of the year. So let's real quick run through these, the most important highlights that you need to know. Number one, remember everybody is online next week. That really doesn't affect you all too much since you're used to that by now. But there you go, all classes, every day, whole week, everything's online and possibly grouped together. So really pay attention to that schedule next week. Speaking of which, next Wednesday is only a half day. All the classes are compressed down to only 30 minutes apiece, so we get through the whole thing by noon. You will report to every class. However, for my class, what I have scheduled there is simply a work day / catch-up day. It's just additional time to work on your work for that week. You'll still have Monday's classwork. You'll still have the week homework on study.com to work on. So that'll just be a day for you to work on that. Hey, I am going to be not just remote, but extra remote because by that day I'll be at my parents' house and having to log in. Okay? So it's going to be real simple. You'll check in Zoom, you're here, great, you're working on stuff, awesome, have at it. Okay? I'm not going to be any more picky than that. And then we come to finals. The final exams are coming up fast. It's, despite our awkward schedule for classes, the final schedule is pretty typical of school so far. Okay? That schedule is already in my master schedule, so you can check the exact time of our class's final exam. When that is, it'll of course be online. The entire week before that, we will spend reviewing. And then the end of that review week will culminate in a review quest, would be the best term for it. I'm going to make it a quiz worth test level points. And of course, because it's a quiz, you can retake it as many times as you need, of course, before the end of the semester, so you don't have a lot of time. But you can retake that to try to get your best score on that. And it'll go in as a test category. Okay? So that should help out your grade if you take advantage of it. All right, any questions on any of those announcements there? No? Excellent. Then let's dive into today's topic, which is still with the rational functions. We're not done with those guys quite yet. We're going to look at increasing and decreasing again with these guys because we get some much more interesting answers from these fellows, right? It's not strictly going up or down the whole way. You really have to watch those turning points. So a few reminders on finding increasing and decreasing. Remember, you're always moving left to right. That is to say, you are always looking for increasing x values. When the x values increases, so I have to move backwards because your camera is reversed, right? From left to right. As x values increase, what is the function doing? Is it going up or is it going down? That's all we're asking. Later on, we will have calculus tools that we can actually compute directly where those regions are of increasing and decreasing. It's pretty nifty stuff. But for now, I would say the best tool you have is the graphs that you've already created. So last week we created our graphs for all of these functions. It's the same set of functions. This is not quite the last time we'll see them. We'll spend a little more time with them on Wednesday. So you're going to look at the graph and say, okay, from this side to that side, going in that direction, is the graph going up or is the graph going down? So clearly we can see this graph from negative infinity all the way up to this vertical asymptote. The graph is steadily increasing. And even though it flatlines out here, pretty much comes in line with its horizontal asymptote, it is technically not on the horizontal asymptote. So from left to right, it is very slowly increasing, and then until all of a sudden it starts increasing very quickly. So you would want to write, in this case, for that guy, the asymptote is at -5. We're going to use our interval notation. So for question 1, we would be increasing from negative infinity to -5. Parentheses again, because the function will never actually reach -5. All of your extrema and vertical asymptotes will serve as those stopping points. So then it would be, is it decreasing? Does it switch? Let's see. It goes from negative infinity back up again. Oh, so it's actually still increasing after -5. But this is a new section, right? The graph definitely had to make a pit stop there on -5. You cannot say across that -5. That can't be in the middle of your interval, right? I cannot say that from -6 to -4, the graph is continuously increasing, because it doesn't. It makes a sudden jump. You go from one value way up here to suddenly negative values. Okay? That's the nature of those vertical asymptotes. They will force you to have a break in your notation. And then the other one would be any of the extrema, any local maximums or minimums, right? The turning points. The graph is literally turning around at that point, which I set here looks to be about at that y-intercept. Do we know it's exactly the y-intercept? I'm not sure. You know, this could be more of a centered parabola here that cuts through and then peaks maybe about there. No, I'm just estimating at this point because I haven't gone and calculated this yet. That's okay. Use your best estimate based on the graph that you drew. So I'm going to stick with that x equal to 0 there. And so we're increasing from -5 to 0. Then we go decreasing from 0 to, what was that next asymptote, +2. And again, from +2 to +infinity, the graph switch to the other side of the asymptote. As seen here, it jumps up here, and then from here on is decreasing yet again. Questions so far? No? All right. Pretty good, pretty good. You might wonder, though, what about holes? Do the holes act as vertical asymptotes? Because it is a discontinuity of the function, is it also a discontinuity of the increasing or decreasing? And I would say, look at function number 2. It has a hole right there. Does this hole look like it causes the function to stop increasing? If I was to compare values on one side of the discontinuity versus the other side of the discontinuity, would that change my idea of whether the function is increasing or decreasing? Right? That's what happens at an asymptote. We compare a value here, right? On one side is a positive value, on the other side is a negative value, so it's definitely gone from increasing, drop, to increasing again. It would be a decrease if we compared those two values directly. But this guy, if I compared a value here versus a value there, I would still show that left to right the function is increasing, which is what it's been doing and what it continues to do before and after the whole. So that whole, because it's a removable discontinuity, I'm able to ignore it for right now, and it does not affect the increasing or decreasing sections of the graph. It doesn't make a break in the same way. Okay? It only misses that single value. Everything else around it still conforms to the pattern. Okay? So no, holes do not stop your increasing or decreasing intervals. They do not need to be the end points of your written intervals here. But the extrema, local maximum, minimums, turning points, and your vertical asymptotes definitely do. Okay, any questions on that? Little twist in the end there. No? All right. Then what you have for the rest of the class period is to, as the instructions on your fresh sheet will indicate, find the increasing and decreasing intervals, just like I have written down here for question 1. Go ahead and find those intervals for all of our rational functions on the sheet. Okay? So you have the rest of the period to work on that. Plenty of time. Of course, if necessary, go back through to your old versions, pull up where you calculated those values for asymptotes and estimated the max and mins, and then pull up your graphs and all that good stuff, right? Use your past work to help you. Don't start from scratch. But with that, I'm going to leave you to it.